cylinder anymore, right?
Perfect. So this is number 28 and 12.5. And Taylor's complaint is that we have x squared over 4 plus z squared equals 1. And we're trying to figure out what the level surface looks like. And he says, well, if I cover up the 4,
then it would be circles with radius 1.
then it's circle of radius 1. And so this is a circular cylinder, right? But with the over 4 in there, I don't know.
It could be stretched in.
What if I told you 4 was 2 squared?
Yeah.
Oh my God.
So in other words, I'm wondering about this thing, right? What if I told you that z squared is over 1 squared?
This is one easier.
You recognize this one from last time? What's this?
This would be, that looks like a elliptical parabola.
So close. Yeah, so you're seeing this isn't exactly on one of your flashcards. This is a little bit off.
It's close to the ellipsoid.
So this is close to the circular cylinder, right? It's also close to the elliptic paraboloid. This shape right here is a, anybody?
Elliptical cylinder?
Perfect. This is an elliptical cylinder. Right, remember a cylinder is just where one of the variables is unrestricted. So in this case, that's good. The y's are unrestricted, right? And this part is just describing what the cross sections are. So these are ellipses, and the y is unrestricted, so it makes an elliptical cylinder. Cool?
Oh, so yeah.
So on your flashcards, right, there's kind of 2 examples of cylinders. But of course, more cylinders could be created by just taking whatever shape and then leaving one variable unrestricted. So we could make sinusoidal cylinders, like the corrugated roof that we made earlier, or we could make hyperbolic cylinders by taking a hyperbola and leaving one variable unrestricted.
I was gonna say, does that mean just like whenever you have like x and z, if you figure out what the shape is on the xz plane, you can kind of just take what that shape is and make it and add the word cylinder?
Perfect.
So
Yeah, and if you want to draw one, right, you go to the xz plane, right? So let me see.
y equals 0. Just
Okay, so I'm drawing on this kind of left plane, right? And I'm drawing a cylinder, right? And it's 1 in the z radius and 2 in the x radius. Okay, so I go 1 in the z radius and 2 in the x radius. And I draw my cylinder. See, and that's going to be behind this thing. And that's going to be in front. I don't know what that one's front. You guys cool with this? So I get my ellipse, right? And then the y's aren't restricted, right? So that shape just gets swept forwards and backwards through the y's, which gives you some, oops. Gosh, you want to be parallel to the axis, though. So you get this kind of elliptical cylinder, right? That's centered up around the y-axis, right? And it's swept out parallel to the y-axis. You guys sort of follow that? This was an example of crappy drawing. Cool? That help a little bit?
Oh, yeah.
So that, yeah, the cylinder thing doesn't necessarily, like this label doesn't really matter so much, except that it matched the picture you're looking at. I did have a complaint about this problem as it is in your book. They wrote this, which is actually 2 separate thoughts.
yeah.
Yeah, so I really kind of wish they hadn't done this, right? Because they don't, when you write equality, you mean that these things are the same thing, right?
Yeah.
And this thing is this is a function of x, y, and z, right? And this is like some separate level curving idea. You guys see that? Okay, so that's my complaint.
So what would the proper way to write that be?
So I would just have written, So in here they say describe the level surface, and then they write this thing in words. And I really sort of wish they had just said describe the level surface of F given by, and then this thing. You guys see that? Because in this equality, it's a little bit unclear whether this is actually the whole function or whether this is just a piece of it that's the level curve or what. Cool.